Good morning and welcome to this webinar. A very big thank you to all representatives from Jabatan Pendidikan Negeri Pulau Pinang, the team from Penang Science Cluster, and also all teachers who are here to join us today. This SNATOMS Molecular Structure Program is funded and supported by the US Embassy. Before we start our teachers' trainings today, we would like to have a short online launching ceremony to thank the US Embassy and all relevant parties for supporting our program. First, we would like to invite the CEO of Penang Science Cluster, Mr. Ui Peng Yi, to say a few words.
Hello, my name is Peng Yi, CEO of Penang Science Cluster. I'm both happy and proud to introduce the SNATOMS Molecular Structures Program, which is part of our Science Kids to School initiative. This program is brought to you courtesy of the partnership between Penang Science Cluster and the US Embassy in Malaysia. Through this SNATOMS workshop, we hope to make the learning of biology and chemistry come alive for our secondary school students. Feedback from our science teachers was that atoms and molecules, the basic fundamental building blocks of all matter, was difficult to demonstrate, and our students struggle to visualize and conceptualize them. Through the use of SNATOMS 3D models, we hope to overcome this and offer much more. Besides learning the sciences, the SNATOMS program will introduce the applications of chemistry in everyday life and the possible jobs in industry. I would like to thank the teachers that worked with the PSC team to develop this program, and to all the teachers that will be helping us to deliver this workshop to their students in the schools. Lastly, I am ever grateful to the US Embassy for sponsoring the SNATOMS 3D kits and for the strong support and collaboration all through the years. Thank you, US Embassy, and do enjoy the workshop. Thank you.
Now, we would like to invite Pengarah Jabatan Pendidikan Negeri Pulau Pinang, Tuan Abdul Rashid bin Abdul Samad, to deliver his speech.
Assalamualaikum warahmatullahi wabarakatuh, and a very good morning to everyone. My sincere congratulations to Penang Science Cluster and US Embassy for launching the SNATOMS Molecular Structure Program. JPN Pulau Pinang has worked with Penang Science Cluster for many years to inject hands-on STEM activities for our students. JPN values PSC's numerous efforts to help our teachers and students. This has made Penang one of the leading states in STEM education in Malaysia. I would strongly encourage all principals and teachers to engage Penang Science Cluster in all programs PSC has to offer, and to work with PSC on developing new workshops for the benefit of our students. Thanks again from me and JPN Pulau Pinang. Thank you.
Now, we have a message from Mr. Bradley Hurst, the Counselor for Public Affairs of the US Embassy, Kuala Lumpur.
Good morning, everyone. It's a pleasure to join you virtually for the launching of SNATOMS, the newest program from the Penang Science Cluster with support from the US Embassy. I'd like to thank everyone at the Penang Science Cluster, including and especially Mr. Ui Peng Yi, the CEO, for putting together this wonderful event and for all the partnership and collaboration we've been able to conduct since 2018 when we first launched the American Tech Corner at the Penang Science Cluster. Things have obviously been very challenging for the past few months, and as I know all of you teachers, as you welcome your students back and think of ways to engage them in this new environment, we hope that SNATOMS will be a new tool for you that can help make chemistry and biology more active and engaging with your students. The partners such as the Penang Science Cluster, which is able to kind of help train teachers across the state and across the country even on these innovative technologies and use of new materials and approaches in the classroom is even more critical today as we move forward. So I would just like to thank everybody involved in this project, and for all of you teachers willing to take this on and try a new approach, which is very important, especially in teaching STEM and making STEM more engaging for students. This is just the first of many programs that we have planned with the Penang Science Cluster this year. Later on, we're planning to launch a new program called Virus Hunter, which is very relevant to given today's conditions, in which students will have an interactive ability to engage with some of the tools that scientists have used to understand the current virus that has been spreading and how to identify and stop new viruses that may emerge. And it'll provide a lot of great information and show what kind of careers are possible for students. So I encourage all of you to also take part in this activity once it's launched. And hopefully we'll be able to do this in person at the Penang Science Cluster in the very near future. But until then, I wish you the best of luck with the SNATOMS program, and look forward to hearing your feedback of how your students respond to this new great tool. Thank you.
Last but not least, a message from the Chief Minister, Yang Amat Berhormat Tuan Chow Guan Yao, to appreciate all our sponsors and supporters, and finally, to officiate this program.
Congratulations to Penang Science Cluster for the launch of the SNATOMS Molecule Structure Program. The Penang State Government is committed to helping Penang schools and teachers develop our students to achieve their highest potential and to build a healthy talent pipeline that will drive Penang and Malaysia forward. To this end, the state government established the Penang Science Cluster back in 2009 to collaborate with the community and industry to inspire our students in science, technology, and innovation. Moving forward, in line with the Penang 2030 vision, the state government will continue to provide support to the Penang Science Cluster, and together we are able to achieve greater heights. In closing, I would like to record my appreciations to the US Embassy for sponsoring this program and partnering Penang Science Cluster to help our teachers and students. Thank you very much.
Thank you for all the kind messages. We will now begin our teachers training session. Thank you. Okay, so a sincere apologize again for just now our technical issue. So we are done with our a simple online launching ceremony, and now let's begin our teachers training. So we will later, because due to unable to live stream it in our Facebook page, later on we will re-upload the video again on our Facebook page. So for those teachers who interested to see it again, you can visit our Facebook page later on after this teachers training session. Okay, so now let's begin our teachers training today. So before I actually start to go into the syllabus, let me briefly tell you about what is the agenda for today. So just now we already had a very simple launching ceremony of this SNATOMS molecular structure program. So later on we will go into an introduction about what is SNATOMS, what SNATOMS can do, and also after that we will actually teach or tell the teacher how to use this SNATOMS in your class, and how will this SNATOMS molecular structure, this whole program works. Okay, and today's program is actually mainly designed for lower secondary science classes. So we focus on the syllabus of the lower secondary science and try to include SNATOMS, this molecular modeling kit, into the syllabus, and so that teacher can actually use this to facilitate the teaching in science. But SNATOMS can actually be used in many other different ways, such as it can be used to visualize chemical equation. It can be used to teach molecular structure as well. So for the other biology or chemistry teacher who join us today, please follow us throughout this session, and let's see how this SNATOMS can help you in your class. Okay, so also just an information, all the slides, all the teachers training materials, and all the videos that we are going to show later, all will be uploaded into the Google Classroom. So even for this teacher training, we will also do a recording and we'll upload it into the Google Classroom later on. So for teachers who actually loan our set and going to conduct these activities inside your class, you will be able to access to all necessary items inside the Google Classroom. So no worries at all. And so now we will be switching our camera to the demonstration part. So yes, please give us 1 minute, okay? Yes. So can all the teachers see the video? So the video now is actually a blank chocolate color tabletop. Okay? If yes, so if you have any question, can put it inside the chat or the Q&A so that we can answer you. Okay, one teacher actually asked how to access the Google Classroom. So later, after the survey form, we will, after this teacher's training end, we will send a survey form, right? Inside the survey form, teacher who indicates that you want to loan this set of SNATOM, we will share the Google Classroom access code with you, okay? Yes, the question got resolved. Okay, so let me do again for how to actually enlarge the video before I actually start. Okay? Yes. So the last one. First, how to enlarge is please put your mouse onto the video itself and then click once. Okay? And then after that, you move the mouse to the bottom left part so that the icon of the mouse actually change into an arrow. After that, you need to click and jangan lepaskan your mouse and then drag it out. And it will become like this. Yeah. So other teachers who are unable to do this can actually do it too. Okay. Yes, so without further ado, oh, is it? Then teacher, maybe do you want to actually change the screens into, you need to switch the slides and also the screen, the video screen, so that you can see a large, so that you can see the larger view of the demonstration and a smaller view of the, you need to click onto the left, you need to click it, then only you can pull it out. So when you see the arrow head, then you need to actually click on it, then don't let go, and then you drag it out. Okay. Okay. So now let's start, okay? So we would like to introduce you this SNATOMS. SNATOMS is actually a molecular modeling kit where the whole box actually looks like this. Okay, this is the whole box of SNATOMS, and when you open it up, there are actually 3 layers. 1, 2, and 3. And inside this SNATOM modeling kit, there are different types of atoms, which you can see the white color one. This is actually a hydrogen. And then this red color one is actually oxygen. And the black color one is actually carbon. Okay, so the idea of this SNATOM sets is actually very simple. It is used to learn molecular structure, and also it can be used to visualize simple chemicals equation. So later on, we will demonstrate how we actually use this SNATOMs to teach students about molecular structures and chemicals equation. Okay, so before we go in detail, let's have a brief understanding on how this SNATOMs actually works. Okay, so let's see this white color ball. Okay, this white color ball here, as you can see, there's actually one flat surface here, and this flat surface is actually representing one reactive site. So this SNATOM balls can be used to represent a group 1 or a group 17 element, which it has only one reactive site that is ready to form bond with other atoms, means like this. Okay, whereas if you see this red color one, they actually have 2 flat surface, which is 2 here. So this actually means that it has 2 reactive sites. So for this red color balls, it can be used to represent group 2 or group 16 elements. Okay, and another very special part of this SNATOM is actually this magnet part. Okay, these magnet parts allow us to feel the attraction force between the atoms. So this very simple design actually can be used to demonstrate the breaking of bonds and also the formation of bonds. So when we teach the students about bonds breaking, we will tell the students that the molecule needs to have bonds to actually break apart, need energy to break apart the bonds, right? So by using the SNATOM balls, they can actually visualize that if we want to break the bond between these 2 atoms, we will need to apply energy to actually break apart the magnetic force. Okay, whereas during bond formation, we teach the students that it's actually releasing energy. So how to demonstrate it is when you put these 2 SNATOMs ball near together, they will snap automatically. So this actually can be used to demonstrate that the bond formation do not require energy, whereas it is used to release, whereas during the reaction, it actually releases energy. Okay? Clear? Okay? So then after, so let's us just put this away first. Okay, so just now the slide is a little bit small, right? So we adjust it, and now it's in full screen mode already. Okay, if do not have any, all the teachers okay until now? Can teachers see the slides clearly now? Yes, okay, cool. So if yes, then we will go into the syllabus. Okay? Yep. So these are actually the list of chapters in Form 1, Form 2, and Form 3, which we designed the SNATOMS activities to fit into the syllabus. So for Form 1, we have 3 chapters. Form 2 we have 2 chapters, and Form 3 we have only, I think, 1 or 2 chapters for Form 3. So this is only just until Form 3, but later on at the end of this, we will actually show other uses of the SNATOMS so that it is more suitable for SPM and STPM level. So next. Okay, so here are the activities that we designed for Form 1, which includes Chapter 5 Matter, Chapter 6 Periodic Table, and Chapter 7 Air. Okay, let's begin. So in Chapter 5, students actually learn about the 3 states of matter. Because this is a Form 1 syllabus, so I think this is the first time that students actually learn about particles inside all the matters. So we can actually use SNATOMS to let the students visualize, make it more clear for the students. So let's try to build a solid, liquid, and gas. So actually in this slide, we only include 3 examples, but teacher, if you have more ideas on building other stuff, you can actually build other stuff as well. Okay, so for the carbon one, what we have here is the carbon nanotube. Okay, so carbon nanotube is a very complicated structure, which we need to actually use 24 carbon atom to do that. Okay, so let me take the carbon atom. So here we have 6 carbon atom. Okay, we will start by first layer, then we will build the other layers. Okay, so each layer of this carbon nanotube is actually made up of 6 carbon atoms. So here we have 1, 2, 3, 4, 5, and 6. Okay, so we will need to match them up like this. Yes, this will be 1 layer of the carbon nanotube. Then we attach this with another 3 layers. As you can see here, got 1 layer, 2 layers, and 3 layers. Okay, we will place this up. Okay, so this is a carbon nanotube that actually can use to represent a solid. What about liquid? So for liquid, the easiest one is actually water. So water is here. So you see the formula of water is actually 2 hydrogen and 1 oxygen. So let's take 2 hydrogen, 1, 2, and 1 oxygen here. And you can see they're actually combined or chemically bonded using 1 chemical bond. So it's very simple. 1 bond and another bond. So this forms the water molecule. So this is for liquid. And whereas for gas, it's also a very common example, which is oxygen. But here, oxygen is a little bit tricky because it is a double bond. So SNATOM actually come with bonds, which is this gray color thing. This is the bonds that SNATOMs created. So we need 2 bonds, 1 and 2, and we need 2 oxygen, 1 and 2. So how to build this structure is 1 bond, 1 oxygen atom, link them up, and then combine with another oxygen atom. And down there, we will put in another bond. So this is the double bond of the oxygen molecule. So this is O2. Okay, this is an oxygen gas molecule. So now we already have a solid, which is carbon nanotube, and liquid, which is water, and gas, which is an oxygen gas. So by building all these examples, we can demonstrate the characteristic of the solid, liquid, and gas. So here we actually include an activity, and this activity is also one of the example inside the textbook summative practice 5. So in that practice, the textbook actually asks the students to do 3 boxes and to see how the particles are actually packed. So here we use SNATOMS. We can do this too. So what we need to prepare is just empty box like this. Any box will do. It can be plastic box, it can be cardboard box. So we will prepare 3, and this first one we will put in the carbon nanotube, which is a solid. Okay, and then another box we will put in liquid, which is water molecule. And then the last one, we will take another box and we will put in oxygen gas. Okay, so we have 3 here. So how to demonstrate the different characteristic of the 3 states of matter? We can take one and shake it. So as you can see, the particles for solids are actually packed together in an orderly arrangement. So you can see that it only vibrates a little bit, and the particles won't actually change place and move around freely. Whereas for the liquid one, you can see when you try to shake it, the particles can actually vibrate in a fixed position. Okay, like this. And whereas for the gas, it will be more loosely packed. The particles are actually more loosely packed. So when when you try to actually shake it, you can see the particles can actually move freely. So this is a very simple demonstration that the students can actually visualize what are the particles arrangement for both solid, liquid, and also gases. And then we have change of states in matter. So this part, we can also use the SNATOMS to actually explain this. So wait, let me clean up a little bit. Here, a very good example to show the change of states in matter is actually water. So water in its solid form, it will actually form ice. And whereas in the gas form, it is steam. Okay? So how this water actually change from solid to water and from water to steam. Okay? So let's show this. Like just now, what I already mentioned earlier, SNATOMS actually teach the students about breaking of bond. So the breaking of bond actually requires energy. And in this example itself, the attraction bonds between the water molecule can be break by using the heat energy. So heat energy. So when applying heat energy, the attraction bonds between this water molecule will actually break, and the water molecule can be moving out freely. So this is how the reaction that change a solid into a liquid. And same as the liquid to gas, when we apply more heat energy, the water molecule can actually move further apart and form steam. Okay, so as teacher can see in the slide, we have a video to actually, this is a video that we found in YouTube, which we think is very suitable for teacher to actually explain to the students about this change of states in matter. So let us have a look with the video.
Have you ever wondered why ice turns into puddles of water on a sweltering day? Keep watching and you'll find out. On Earth, materials exist in one of three main states of matter: solid, liquid, or gas. Materials can change between these states. When a state change occurs, a substance's property will also change. Maybe not too surprising. However, if the state change is reversed, the substance will recover the properties it had to begin with. Neat. Matter can transition between the three states when heated or cooled. But why is heat key in all of this? When a material is heated, it absorbs heat energy. This additional energy can cause attractive forces between molecules to break. This leads to rearrangements of the particles because the attractive forces no longer hold them together as tightly. The same happens when a liquid is heated. The attractive forces between the molecules break, leading them to become more widely dispersed and a gas to form. These four words describe changes in state. Do you know which word refers to which change? Pause the video, fill in the gaps, and click play when you're ready. Did you get them right? Do you know the difference between evaporation and boiling? Both are when a substance transforms from a liquid to a gas. Think of a boiling pan of water. All of the water bubbles. This is because all of the particles have enough energy to become gaseous. But water standing in a pan that is not being heated by anything other than the environment can also turn into a gas. This is evaporation. Only the particles at the surface have enough energy to change from a liquid to a gas. Hence, evaporation is a slower process than boiling, even though it achieves the same state change. Both are types of vaporization. The opposite of these vaporization processes is condensation, the transition from a gas to a liquid. Think of a cold can of soda on a hot day. Those water droplets on the outsides, or the dew on the grass in the morning, or the steamed up mirror after a hot bath, even the clouds in the sky, or a foggy windscreen in a car. These are all examples of condensation. Water vapor in the air has cooled down to form liquid droplets of water. Now let's think about the transitions between solids and liquids, so melting and freezing. Think of the Arctic sea ice. In the summer, when air temperatures are warmer, more heat energy is absorbed by the ice. This causes bonds to break between the ice's water molecules and the ice starts to melt. The solid ice becomes liquid water. But in the winter, the air temperatures are colder, and so seawater freezes, and the ice starts to form again. There is less heat energy within the ice, and so more bonds can form, holding it together as solid ice. So far, so good. But did you know that sometimes when solids are heated, they can turn straight into gases? This is called sublimation. This is only demonstrated by particular materials such as solid carbon dioxide, also known as dry ice. When subjected to a certain pressure, it will turn straight into gaseous carbon dioxide. Liquid carbon dioxide does exist, but it only occurs under very high pressures. Similarly, gases can turn straight into solids when cooled. This is called deposition. Let's check out how much you remember about the changes of state. Pause the video and fill in the blanks. Did you remember them all? Our final thing to discover is that when a material changes states, the mass stays the same. The density changes, so the mass per unit volume, but the mass does not change. Our glass of nice cold Coke weighs the same whether the ice is solid or when the ice has melted. So there we have the changes of state. Just remember that the mass stays the same whatever the state.
If you Okay, so some teachers actually said that the slides is not very clear, it's a bit blur, right? So let me adjust and see if it will be better or not. So is now better? Can some teacher give me a response? Yes? Okay. So can we continue? Okay. So just now is just for the just now is actually one example of the videos that we found it very useful for teachers to actually explain about matters and stuff to the students. Here we include other videos which explain the 3 states of matters, some particles within the matters, and also the just now one, the changing of states of matter. So all of this video will actually appear in the Google Classroom, so no worries about that. Okay. So now we go into chapter 6. Chapter 6 is about periodic table, but in Form 1 syllabus, the students actually learn about only elements, compound, and mixture. And I think SNATOMS is a very good tool to actually show the to differentiate among elements and compound. Okay, so for the element one, we actually include 4 examples, which we have oxygen, and we have nitrogen, and the carbon bulky ball. That one is a complex structure, and also the simple one, hydrogen. Okay, so these are the example of elements that SNATOMS can build. There are actually much more which teacher can actually explore. And since we already know how to build the oxygen, and hydrogen is a very simple one with just 2 hydrogen atoms, link them up together. So now let us learn how to build the nitrogen. Okay, so nitrogen is also a very simple molecule, which it is a triple bond. So like I said, SNATOMS actually come with bondings. So this gray color one comes again. So we have 1, 2, and 3. Okay, and then 2 nitrogen atom. So as you can see, the nitrogen atom here, there are 3 flat surface, right? So these are also 3 flat surface. Okay, how to do it is you just take 1 nitrogen atom, then put it here, and another bond, put it here, and another bond, put it here. Then here you can see another nitrogen bond. There are 3 flat surface as well. So you just need to match the 3 surface in. So here is the nitrogen molecule. Okay, N2. So let's bring back all our elements. We have the oxygen, and we have the hydrogen and nitrogen. What are the similarities between all this? They are just made up of 1 types of atom balls. So you can see this one is the red color atom balls. Oh, sorry. Red color atom balls. This one is just made up of the blue color atom balls. And this one is the hydrogen ball. Okay, so this indicates that elements only consist of same type of atom. Okay, so we put it aside first. Later, when we build the compound, then we compare again. So what is compound? Compounds are actually elements that molecules that consist of 2 or more elements that combines together chemically, which is the definition. So how to show this definition to students is by using SNATOMS. So what we have here, we have hydrogen, we have water, H2O, then we have carbon dioxide, CO2, and another one is glucose. Okay, the glucose and the acetic acids is more complicated, so we will demonstrate how to build it. Whereas for the water and the carbon dioxide, it's pretty simple. So these are the example. Okay, since we talk about glucose, so let us build a glucose. Okay, so glucose is actually, the formula for glucose is actually C6H12O6. Okay, that means what we need is, we need 12, we need 6 carbon, 1, 2, 3, 4, 5, and 6. And then we need 6 oxygen. 1, 2, 3, 4, 5. Oops. Oops. It's okay. 5 and 6. Let's put it further a bit. Okay. Then the last one is we need 12 hydrogen. So these are 2 combined together. Okay. And 12. Okay. This is a biomolecule, so it's a bit complex, the structure. So let's start. How to build it is, first we take 5 carbon and link them up together first. 1, 2, 3, then 4, 1, 2, 3, 4, and 5. Okay, then this is C5, and in the middle of C1 and C5 we will add another 1 oxygen. So it should be something like this. Then if we can count it, is C1, C2, C3, C4, C5, and C6. Okay, and then in this C6 part we will add O and 2 H. Okay, then for each of the carbon we will attach 1 oxygen with it. So 1, 2, 3, 3, and 4. Okay, like this. Then we will the remaining reactive side we will just put our hydrogen. Okay, so put 1, so put 2, put 3, 4, okay, 5, 6, 7, 8, 9. One more is here, 10. Okay, so this is a glucose structure. C6, H12, and O6. Okay, so this is a most complicated one until now. So this is glucose. So let's bring back our compound. We have our carbon dioxide and also the water. So how to differentiate this compound with the elements? As you can see, it's obviously you can see there are more than 1 types of elements that are combined together. So in real scenario, they're supposed to combine it together chemically, but here we just snap it. So for this water, there are actually 2 elements, which is the oxygen and the hydrogen. And for the carbon dioxide, there are 2 elements too, 2 types of elements too, which is the carbon and the oxygen. And for the glucose itself, it consists of 3 elements, 3 types of elements, which is the carbon, oxygen, and hydrogen. Okay, clear? So what about mixture? So for mixture, we can combine the mixture part with chapter 7, which is air. Okay, so let me clear these things out first. So inside the air actually consists of nitrogen gas, oxygen gas, carbon dioxide, and also other inert gases. So all this compound, the students actually know how to do it if we already run through the previous few chapters. So teachers can actually challenge the students by just giving them an empty box and a set of SNATOMS. So the students are going to build the nitrogen, hydrogen, oxygen, and carbon dioxide themselves, then put them all inside this plastic, this empty box. So we have nitrogen here, we place it in. We have hydrogen, which is the inert gas. So this we put more, and we have oxygen. Let's find more oxygen. Yeah, we have more oxygens, and we have carbon dioxide. Yeah, all inside these containers. So is this a compound, an element, or a mixture? So it's actually a mixture as it has different types of elements and compounds that mix all together here. Okay, cool. Yes, so this is actually a challenge that teachers can do it with students, and I think students will be having fun in building all this. Okay, so for the nitrogen, oxygen, and hydrogen, we already learned how to build them. So now let's build the carbon dioxide. Okay, here, carbon dioxide. Oh, where's my carbon dioxide? Okay, it's here. So for carbon dioxide, the formula or the structure is like this. We have a double bond that binds the carbon and one oxygen in this side, and another double bond which binds the carbon with another oxygen atom. So up until now, I think it's pretty simple already for teachers to actually do this, but I will still just a quick demonstration. So here we can count, we need 1, 2, 3, and 4 bonds. So we will take 1, 2, 3, and 4 bonds. Okay, then we need 1 carbon atom, which is a black color carbon atom, and we need 2 oxygen atom. Okay, so let's build this part first. We will combine this middle carbon atom with 1 oxygen atom. So we bind, double bond, and link them up. So this is this part. Whereas for this part is the same. We will attach 2 bonds with it and snap them. Yes, so this is a carbon dioxide, CO2 with two sides of double bond. Okay? Yes. So now in the air we got hydrogen. No, so some teacher actually ask where is the hydrogen inside the air. Oh, okay. We'll resolve that later. Okay, let me finish this part first. So now we have this carbon dioxide here. Since we already have this carbon dioxide, so let's try to use SNATOM to build the. Let's try to use this carbon dioxide to learn about carbon cycle. Okay, so how to do this is first we start from the top. Okay, CO2 are actually in the atmosphere. So this is the CO2. So during photosynthesis, the plants actually takes up the carbon and release oxygen. So we take out the carbon and it will release the oxygen. Like this. Okay, so this oxygen will actually release to the atmosphere and we remain with the carbon inside the plant. Okay, this carbon will be inside the plant, and when the animals or any creatures that actually feeds on the plants, they will eat the plants, and this carbon will together with the plant, it will goes into the body of the animals. And during excretion, animals constantly release methane gas. So methane gas is actually CH4. 1, 2, 3, 4. Okay, this is methane gas, CH4. And this CH4 will release into the atmosphere and combine with the oxygen. Okay, so they will combine and they will react. So this reaction is the combustion of methane gas. So we have the formula here, or we have the equation here, which is we have the CH4 and we have oxygen. So for a complete equation, balanced equation, we will need 2 oxygen. So methane gas, 1 oxygen And let me get another oxygen. So these are 2 oxygens. Okay. Then in a combustion reaction, it will produce product, which is the CO2, carbon dioxide, and also water, means 2 H2Os. So let's see if this methane gas and oxygen would be able to change into carbon dioxide and water or not. So first, the CH4, we will take out the hydrogen, and then we will put the oxygen and another oxygen here. So this is the carbon dioxide that released as a product, and the remaining one is obviously we have 2 oxygen atom and 4 hydrogen atom. So we can build this up by just link them together, 2, like this. So 2 water molecules and 1 carbon dioxide. So this is a very simple demonstration on the equation. Okay? Yep. So that's all for the chapter 7. Do you have any questions so far? Ooh. So one teacher actually asked about the magnet strength. So no, the magnet strength won't get what I can't see. So the magnet strength become weaker as times go by. So far we already use it for like few months. I don't think it's an issue. Will be like the common fridge magnet at home. This one we will need to try it out, and after we loan it for like 2 months, then we will check if the magnet strength will be weaker or not. Okay, but so far, for now, we like drop it quite a few times and we just play it around. That is fine lah. We didn't find any issue yet. And the teacher actually asking about the hydrogen part. Okay, so I'm sorry, I'm not that sure about that. So let me check, and at the end of the session, I will go back to the teacher, to you, for that question. Okay, I'll do some reading to make sure I didn't get wrong statements or anything. Okay. Yes, it's all clear now. Oh, okay. And there are questions that the teacher says that the internet connection are not that good. So we know that we also facing this issue quite often in our office here. So we will we have this recording in ongoing. So later on, we will convert it into videos and we will put it into our YouTube channel. So after this teacher training, we will actually share the link to all the teachers who joined us today so that you can have a look, like refresh back what is going on inside this teacher training. And also just to let you know, all the slides and all the videos, we already compile it like chapter by chapter and form, like form 1, form 2, form 3, form by form inside the Google Classroom. So for teachers that wanted to do this for form 1 students, you can directly get the whole package of the slides, the videos, and all the even extra information inside the Google Classroom for you to actually run the class. Okay. Yeah, so there's a good suggestions from a teacher which they think that this carbon cycle is way too simple for students to actually understand in deep. Yeah, but this is a tiny part of the disadvantage of this SNATOM balls, because it cannot really show a very complex biological process. Yes, yeah, but this is just to we try to design this as is more easy for the teacher for the students to actually visualize this carbon cycle. Oh, so one teacher actually asked where can we get the model. So that's why we do this program. So after this teacher training, teacher can actually indicate the interest to loan this set, and we will loan this to the teacher to each schools 5 sets, and teacher can run this activities with their students. Okay, so the details of the loaning process and about the program we will talk again during the end of this teacher training. Okay, yes, any more question? If no, then we will have a 5-minute break, and after that we will let Wen Yun to conduct the syllabus for Form 2, Form 3, and also for upper secondary. Okay, so now let's share the LTP QR code. Okay, so like I said just now, during this 5-minute breaks, it's time for you to claim for your LTP marks and also check your attendance. Okay, so now we already share the QR code onto the slides. So for teachers, okay, wait, let me stop the video. Okay, so teacher can actually try to scan this QR code and put in your IC number to claim for your LTP marks. So for teacher who are unable to do that, please drop us your name and your IC in the question and answer part. Okay, we will jot it down and we will send it over to JPN later. Okay.
So teachers, we have 1 minute more. I hope you guys can hear my voice very well. So I'm Wen Yun. So we will have a very short, let's wait a bit more. We will start at 11:18 sharp. So for teachers that have raised up their hands, can you please let us know what happened, or you can drop us a Q&A. Also from Puan Sofiazan, do PSE loan the SNATOM models to schools? Yes, we will loan these SNATOM models to school. So each school for now, we set it as 5 sets. So if there's any request that we need to increase the set amount, we will check it again. So is there any more questions? So for teachers that raise up their hands like Puan Juhara or Afiza Musa, please leave your questions. Oh, this QR code you don't have to attach any photo for this QR code. The one that you need to attach your photo will be at the second QR code at the end of these sessions. So yes, do I answer your questions? Okay, cool. So you will only post your photo at the end of at another QR code at the end of this session. I need to warm up a bit. What is the URL code for? So this URL code is more likely to be a check-in for you guys so that we can tell JPN saying that you already come and you attended the first part of these sessions. It's like check-in. We need to, so yes. So just now we have one teacher mentioning about the hydrogen gas. And for information, hydrogen gas do exist in the atmosphere. However, it's at a very minimal amount. So it does not really show up in a chart itself. So besides, it is not actually listed in the science form 1. So teachers, you can actually decide whether you want to put it inside your syllabus. And for information, we will actually amend our slide for this case. So hydrogen is not an inner gas. All right. So cool. For the question, is there any form that teachers has to submit? Yes, if you want to loan, we will actually provide a survey, the registration form of interest later on after the end of the sessions. So great. Are you guys ready? So I believe being a teacher for an hour is hard. So I'm going to be the second teacher of these sessions. So for my part, I will cover Form 2, Form 3, as well as some additional information regarding the syllabus that we can utilize in upper secondary school. So good, everyone in, I should put here. So no worries. So we will shortly start our Form 2. So just now, we already go through a few items from nitrogen gas buildup, oxygen gas buildup, and also glucose. So we're gonna go deep down a bit for this session. So because it's Form 2, and in Form 2, we realized that SNATOM could be fitting for the Chapter 3, Nutrition, as well as the Chapter 5, Water and Solution. So without further ado, we will go into Chapter 3, Nutrition. So in this chapter, we all know that students will gonna learn biomolecules in this chapter of nutrition. The biomolecules that we aim to teach them could be carbohydrates, protein, and also fats. So we will start with carbohydrate. So as we all know, glucose is the basic building block of carbohydrates. So you can see now there's one glucose here that we have, that we know that the glucose formula is C6H12O6. So we'll refresh again. The black one here, right here, is the carbon. The red one is the oxygen. And last, the white one is the hydrogen. So the carbon, we have 6. Let's do a proper one. This is carbon number 1, carbon number 2, carbon number 3, number 4, number 5, and number 6. And we have 6 oxygen as well. 1, 2, 3, 4, 5, 6, and last, the 12 hydrogen. So what we're gonna do in this session, we're gonna illustrate how does a condensation of glucose unit to form a polysaccharide. So we're gonna form a 1,4-glycosidic bond. So let me bring in other glucose unit here. It's a very big molecule, and what is good for this set is you can actually let the students see the shape itself, that is the hexagon shape. So I'm gonna move a bit. This is 1. This is correct. So how to start a condensation process reaction? So first of all, we will remove the hydroxyl group from the first unit of glucose. Here I have 1 OH, and next I will remove another hydrogen from the OH group of the carbon number 4. So here come the hydrogen and the hydroxyl group to form the first water molecule. And from the first glucose unit, you will see there's a reactive site from here, and there's another reactive site from the second glucose. So here we were gonna bind these two glucose together and form the 1,4-glycosidic bond. So the first 2 units of glucose are bonded now. Now I'm going to move on. Oh, I should move further into it so everyone can see it. So great. So for the second 1,4-glycosidic bond, I'm going to move it so that everyone can see it properly. So here I am. Again, the same thing. OH from the second unit of glucose. I'm going to move out here. And there's another hydrogen from the carbon number 4. 1, 2, 3, 4. Carbon number 4. So it formed the second water molecule. And with this, the reactive site of the second molecule and third molecule can bind it together. So here we have 3 units of glucose being bonded by a 1,4-glycosidic bond to form a 1 chain of polysaccharide. So in this case, because it's a 1,4-glycosidic bond, it's a amylose. I'm about to say amino acid, that's bad. So from 3 condensation of 3 units of glucose, we actually form 2 units of water molecules. This completely illustrates the condensation of the glucose with the removal of water molecules. So here comes the end for our carbohydrate sites. Not to forget, we're gonna move on to protein. Again, yes, this is how I illustrated just now. The 3 glucose unit will have 2 water molecule as the product of the condensation reaction. So great, we are going to move on with amino acid, because as we all know, amino acid is the building block of protein. So amino acid, there's a lot, there's 20 types. So however, today we'll only do for 3 types. So what can we do for now is we're gonna build amino acids. So we all know that amino acid generally have 4 parts. The first part will be the amino group, which is NH2. Second will be carboxyl group, COOH. And number 3 will be the hydrogen group, hydrogen atom. And last, it will be the most specific one will be the R group, which gives the characteristic of the amino acids. So here comes, I'm going to start with alanine. So how are we going to build a alanine? So this is the formula, which is C3H7NO2. So are you guys ready, teachers? So for now, I will start with 1 alpha carbon. This alpha carbon, we're gonna bond it to all 4 functional groups for now. So I will start with NO2. N is the blue color, and then white is the hydrogen group. So I will attach this NO2 amino group into this alpha carbon. So second, I will move on to the hydrogen atom, which is the simplest one, to the alpha carbon. And next, it will be the COOH, carboxyl group. The C is having a double bond with the O, and another side of the carbon will have the OH. So I will bond this together. So for now, we have 3 parts ready, and what we are left with is its R group. So the R group for alanine is CH3. So I just can't figure out the word that comes to my mind, the CH3 itself. So now here I have the alanine, complete alanine with 3 carbon, 7 hydrogen, 1, 2, 3, 4, 5, 6, 7, and last 1 nitrogen and 2 oxygen, the red oxygen. So this is a complete alanine. So teachers are encouraged to actually give students the formula so that the student can actually build up the molecule by themselves. Lower secondary school science may not actually cover all amino acid, but I believe upper secondary school for their science subject, they actually need to know quite a lot of the amino acid, also to understand their special characteristics such as hydrophilic, hydrophobic, or even more distinct characteristics. So followed by understanding the amino acid, we will do the condensation part of the amino acids to form a polypeptide chain. So yes, so right here we have the alanine that we built just now, and the simplest ever amino acid, which is glycine, that has R group just H itself, and serine, which have CH2OH right here, CH2OH as their R group. So I'm arranged just same as the formula we show on the slide. So I'm going to start again with our condensation reaction. So what we're going to start this time is, I'm going to do some arrangement first, or else a little bit messy. So we'll remove the OH from the COOH of the first unit, which is the glycine, and I'll remove the H from our amino acid. Here we go, having the first water molecule, and second, seeing that there's an empty site here, we will snap them together to form a complete, okay, let me have a look. Okay, to form a peptide bond between this C and the N. So right here, we have our first peptide bond. Now I'm going to link our glycine to serine. So how are we going to do that? It's the same like the first peptide bond. You remove the OH and another H from the amino group of serine. So in here, you will see, this reactive site, then we will plug in here. So here we go, having the polypeptide change. So this is just a linear change. However, to make it a functional protein, we will actually need to go through secondary, tertiary, or even quaternary to make it a functional protein. So don't worry, I hope this thing could actually help teachers to make students understand about the structures of the amino acid. Because when I go into university, I was required to actually list out all 20 amino acids and knowing their R groups. So this could help students to have a better understanding about the amino acid. So yes, they need to coil so that they become functional. So after we have both carbohydrates and protein, the last we're going to come to fats. You can see fats is built out of triglyceride, which is 1 glycerol followed by 3 fatty acids. It's a very big molecule compared to our amino acid as well as glucose. So instead of teacher building it up, we're gonna take forever for teachers. So how about teachers will ask students from different groups to create different parts of the triglyceride. So one group will actually build glycerol, another 3 will build the fatty acids. So lastly, you can ask the group of students to actually do the condensation together and form a complete triglyceride. So in here, we actually illustrate only the saturated acid, which is hexanoic acid. To make it more challenging, teacher could also provide them specific fatty acids such as oleic acid or even palmitic acid to make it more exciting activities. So when we finish and complete that, I would say we actually complete chapter 3 for Form 2, Nutrition. So for now, we are going to move on to Water and Solution, which is the chapter 5 for Form 2. Is there any question from teachers? So is it too easy that, yeah, I'm going to do it? So in this chapter, we're going to teach students about solution. So what happens in this chapter, we're going to teach students about the solute, the solvent, as well as the solution. So what are the solute that we are trying to illustrate in today's class? It will be sodium chloride, which is the common salt that we find in our kitchen. So in here, the group 1 sodium is illustrated by this gray color one-sided atom, and the green one, which is what we can think of chloride when the color is very similar when chloride is in their supersaturated gas form, the yellow-green color. So we're going to bind this group 1 atom to group 17 atom together to form this NaCl. So it's a very direct one, so I believe teachers has no problem with it. But to actually enhance their learning, we actually put in also solvent, which is the H2O of the day. And to illustrate solution, this is a mixture of form when the solutes dissolve in a solvent. So no problem with this definition. So for now, we're gonna move on to a very simple activities, which is we're gonna bring in 2 large beaker. And we have lots of NaCl as well as water molecule, because we're going to illustrate what is dilute solution, what is concentrated, as well as saturated. Oh, that's 1 hydrogen gone. Yes. So to illustrate the different concentration level of the solution, we actually design it so that the student can see what are the different. Yep. So we actually encourage, if when you are doing these activities, you have another student at your side that have 3 also beakers, but they are not having SNATOM. They're having the spatula, the water, as well as the salt, so that they can put in the amount of the salt when you are putting in a SNATOM. So for the dilute solution, we will put in 6 water molecule, which is 1, 2, 3, 4, 5, 6. However, with only 1 unit of NaCl. Definitely, this one will have very little taste of salt. And the second one, a concentrated one, 3 molecules of H2O and 4 molecules of NaCl. And last, we have 5 NaCl and 2 hydrogen water molecule. So we can see that this one having more NaCl at a very low amount of water molecule. Let me breathe in. I'm feeling I'm rapping. So in a general case, you can see dilute solution will have a lot more space to let the solute to dissolve. However, for concentrated solution, they have very little space for solute to dissolve. And last, saturated solution will have excess solute and they can't dissolve any more solute, especially NaCl for this case. So here comes the end for our chapter 5, water and solution. So that's it. Do you guys have any question, teachers? We are happy to answer question right now. So for gray color, it's represent alkali matter. So the white color is the hydrogen atom, and the green color is about group 17 elements. So actually they have different color. I hope it illustrates better now if I put it up here. Do you see the difference, teachers? Okay, great. So if there's no more other question, we will move on to the Form 3, which is reactivity of metals. So in this chapter, they have a more illustration regarding the metals elements, but we can actually use SNATOM to illustrate a certain structures of the chemical compound. So in the first chapter, we know that quartz is a buildup of silicon dioxide. So this structure is exact the illustration of the one on the right hand side. However, this is more common to be found for quartz, but for other compounds that also have silicon dioxide, in a different arrangement, teacher could also use SNATOM to help illustrate it. So I have another one question for teachers since I've been talking for so long. So there is one question that I would like to ask questions. So we have ferric oxide on our reactant and carbon. What could it be the product of this equation? I hope that's teacher answering me. So, oh, okay, somebody answer on the, okay. It's all right if you are not good, because you can't actually voice out, you can answer on the chat. What is the product of this equation? Can anyone tell me? So, it's okay, great. I see someone replying me, it's fine. And it's a correct answer. So, yes, we have teachers that answer me the correct answer. Yes, the answer, the product is the iron as well as the carbon dioxide. So this is a reaction of the hematic extraction, which is the iron ore. So you can actually illustrate this thing to students so that they could understand that what they find in the atmosphere, they must go through an extraction process in order to get a pure metals. So cool. So to help students to have better understanding on this chapter, we actually provide a series of videos that could help explaining reactivity series of a matter and also extraction of metals from their ores. So I'm not just gonna wait them to set up a little bit. So this is all about the chapter 3. So after the video, we will talk about shortly about what other uses of SNATOM that we can actually bring it to schools, to our students know that what they can try to use. So here comes the videos.
You may have noticed that most of the elements in the periodic table are metals. All metals have similar physical and chemical properties, but not identical. By looking at a small number of metals, we can investigate how they vary chemically. We will look at zinc, copper, potassium, calcium, iron, lithium, magnesium, and sodium. First, let's look at the results when a small amount of each is dropped into cold water in a test tube. Stop the video to study the results, and then try to rank the metals from most to least chemically reactive. How did you do? From the results, some can be ranked, but others appeared to be the same. Let's rewrite the list. If the experiment is repeated with dilute hydrochloric acid, we can reveal the different chemical reactivity of the metals that have not yet been ranked. And now, rewrite the list again. From these two experiments, we can rank all 8 metals in order of chemical reactivity. This is of course a selective list, or else we would need to include over 70 metals. This gives us the reactivity series of metals, many versions of which you will find in books and online. You may already have known that lithium, sodium and potassium were at the top of the list, since we store these metals in oil to stop reaction with moisture in the air. When potassium reacts with hydrochloric acids, we get potassium readily loses an electron to form the K-positive ion, whereas when zinc reacts, Zn will form its ion Zn2 positive, but less readily than potassium does. So the series of reactivity is also a list which shows the tendency for metals to produce their positive ions. Don't panic, you don't have to remember this list. You should, however, be able to rank metals if given results of an experiment, and then be able to use the list to answer further questions, such as in explaining displacement reactions.
If you liked the video, give it a thumbs up and don't forget to
So great. We just finished watching a very simple video talking about the reactivity series of matter. I hope you guys enjoy and find something that it's useful for the classes. So right now, since we have finished the lower secondary science program, and if you find it like, oh, there's more you can do, we are happy to actually accept your welcoming or your opinion, your input, or even if you think that there are syllabus that we can actually add on, especially to our Google Classroom, please let us know. Later on, we will actually provide our contact so that you can contact us using that email and also our contact number. So without further ado, we're gonna move on to the other uses of SNATOM. So just now we illustrated all three forms. So right now, to be a little bit more deeper, this SNATOM is a very useful to teach organic chemistry from alkanes, alkenes, alkynes, alcohol, as well as carboxylic acids. So we actually will have another video from Derek, the founder of SNATOM Kit, where he actually have a very good explanation of how to use SNATOM to teach alkenes, alkenes, alkynes. While waiting for our colleagues to actually set up the videos, I would say these 3 items or 5 items is something that we learned during Form 6 or Form 6 items that we will learn starting from the saturated, the unsaturated, for even more complex functional group of this organic chemistry. So here we have the video from Derek, the founder of SNATOM Kits. Great. We'll come back this later. We'll come back this later.
Let's talk about 3 common types of molecules: alkanes, alkenes, and alkynes. What are these things? Well, the alkanes are pretty simple. They are molecules that are just made of 2 elements. We have carbon and hydrogen. So the simplest alkane we can make is a carbon bonded to 4 hydrogen atoms. That gives you methane. Meth basically meaning 1, and ane is the ending for all of the alkanes. Methane. This is what comes out of your stove when you're cooking. This is natural gas. What if we add another carbon and we complete this molecule with more hydrogens? Well, we've got 2 carbons now, and so that would be F is the root of that word, and the ending again, ane. So this is ethane, ethane. Let's add 1 more carbon, Now we've got 3 carbons, and how many hydrogens do we have? 1, 2, 3, 4, 5, 6, 7, 8. So if you were to write down the molecular formula for this, it would be C3H8. And if you have 3 carbons, then the start of the word for this molecule is prop. So we have propane. This is what you would use when you're cooking in your barbecue. You can see that a lot of alkanes are used for fuels. For example, we add 1 more carbon, then we have 4 total carbons, and the way to name this is bute for the 4 carbons, and then ane because it only has hydrogens bonded around this. So this is butane. You might be familiar with a butane lighter. Let's make another fun alkane. I'm just going to extend this carbon chain out to 8. So we have 8 carbons now. What would that be called? 8 is often oct. So now we have formed, when I finish off all the hydrogens, octane. And this is one of the most important molecules in gasoline. So this is what would fuel your car. Octane, plus a mixture of other things. What's interesting to notice about these alkanes is that because they're all single bonds, I missed one. Because they're all single bonds, there's a lot of rotation which is possible. So these molecules are really quite flexible, and they'd be jiggling around and moving all around in these different configurations. In fact, one of my favorite molecules to make is hexane. So right now we have hexane for 1, 2, 3, 4, 5, 6 carbon atoms, and you can actually form this around into a loop to make a ring of carbons containing 6 carbon atoms. Let's see if I can do that. Perfect. And this is now called cyclohexane. Cyclo because it makes a little cyclic ring, and hexane because there are 1, 2, 3, 4, 5, 6 carbons. That is cyclohexane. So those are the alkanes, simply made of carbon and hydrogen. What about alkenes? Alkenes contain a double bond. So let's say we take 2 of these carbons, and instead of just single bonding them, so they can rotate, we double bond them. Again, you remember that means that each carbon is actually sharing 2 outer electrons with the other, so that fills 2 bonding sites on each of the carbon. So if I double bond the carbons, now we only have C2H4. We can fit fewer hydrogens around these carbons because they're double bonded to each other, and this is called ethene. Eth for the 2 carbons and the ending ene because there is this double bond. We could make propene by adding another carbon, so we use the word for 3, prop, and we add ene, propene. Again, we could make butene, but instead, why don't we make propyne? So if we want to add a triple bond in here, so now we have these carbons forming a triple bond with each other. This is what we call an alkyne. Again, fewer hydrogens are possible to bond on here because we have triple bonded the carbons together. So this would be propyne. What about that? What would that be called? That, because of the triple bond and the 2 carbons, would be called ethyne. That is a brief introduction to alkanes, alkenes, and alkynes. 3 different kinds of molecules you could form.
So great, I hope this video from Derek actually inspired you a little, because it was his own creation of this, and he also himself a chemistry teacher. So without further ado, we are going to move on with another part, because other than illustrating structures, I believe this SNATOM could be a very good way to actually teach students about reactions. So what reaction we are trying to do today is combustion as well as esterification. So let's start with combustion first. Combustion is a very common reaction that we often see, and this today example will be on ethanol. So ethanol will react with oxygen, and for this case, it's a complete combustion to give carbon dioxide and hydrogen water molecules. However, this is not a balanced equation yet, so we will do the calculation together. So bear with me, teachers who are already super good on this calculation. So since ethanol is the limiting reagent here, we will start with the C. So C, we have 2. So to make sure C is 2 atom on the product, we will also double up our carbon dioxide to get a 2. So we have C complete. So followed by H. So how many H do we have in our reagent? We have 5 plus 1 equal to 6. So to make sure that we have 6 hydrogen on as the product, we will actually triple it up to make a 6 atom of hydrogen. So we have done with H. Now we are going to do our O. So how many O do we have from the right hand side? So we will have 4 plus 3 equal to 7. And in here, in our ethanol, we already have 1. So we bring it down. So how many equals to 7? It will be 6. So let's use SNATOM to help us visualize whether this reagent will give us these 2 molecules of carbon dioxide and 3 H2O. So we have 1 ethanol right here. I just prepared it earlier on. And triple out our oxygen. Sorry, everyone. So it's 3 oxygen right here. So I'm gonna make sure I have 2 carbon dioxide and 3 H2O without bringing any other stuff from the outside. So I'm gonna bring out the C first. C is right here, and followed by the carbon dioxide. So great. I'm just taking bonds. So great. I have my first carbon dioxide. Now I'm going to have my second carbon dioxide. Ching, ching, ching. Sorry, I just moved out of the camera. It's all right, as long as you can hear me. So here we have the second carbon dioxide. Great. So are we going to build our hydrogen gas now? Water molecule. So 1 plus another hydrogen. The first water is done. Second, oxygen plus 2 oxygen, done. Number 3, we have our complete combustion of ethanol combustion. So SNATOM could help you to actually visualize whether your calculation or your equation is actually complete or not. So other than combustion, we are going to do esterification as well. Esterification is a reaction between a carboxylic acid with an ethanol. So this is already a complete equation, so I'm not going to do the balancing for you guys, but we have the ethanol. So this is the acetic acid. So how does this process works? It will need another concentration acid, but we are not illustrating here. So we will move the hydroxy group from the carboxylic acid of the acetic acid. We move out the hydroxy group. Then we'll remove the hydrogen atom from the ethanol. So here we have the oxygen bind with the carbon. So here we have, let's move it this way. This is the ethyl acetate. So the last thing will be our water molecules. So other than illustrating or visualizing the equation, reaction equation, SNATOM could be a very good tools to actually help illustrate the geometry structures, because for a higher level of chemistry, they actually needed to tell what's the angle, so on and so forth. So using SNATOM, you can help illustrate angular, trigonal planar, or even trigonal bipyramidal with SNATOM set. So this is all about the syllabus that we have thought of. So other than this, we also give some additional information in our Google Classroom, such as a video that tells us why are we learning chemistry? How does it actually affect us or to the society? And next, it will be about the future of chemistry, what it is out there for us to understand chemistry in the coming years. So that's all for the teaching parts of today's session. We have covered lower secondary science as well as certain part of upper secondary sciences, chemistry or especially chemistry, not biology yet. So if you have any question, please let us know, because we are going to move on to brief about how does our program SNATOM Molecular Structures works with teachers in Penang. So in PSC, we actually provide teachers training like today to all teachers that are interested to take up our SNATOM molecular structures. We will deliver the SNATOM set to you teachers, and teachers, we will use it, the SNATOM set with your students and return it to us. So at that point, we are glad if you can give us some feedback so that we can improve our Google Classroom materials or even making this loan setting even better. So how does it work? It actually starts from today. The teachers training we have to teach about how we can use SNATOM. So after this, we will have the QR code again to lead you to the survey. And in that survey, it also serves another registration of interest, whether you want to loan it for your classes, for your school. And a very short time, we will start loaning out the first 10 school in the 1st October, and the loan period will until 28th of October. So every school will receive 5 sets of SNATOM, and the Google Classroom material will also attach, or we will provide the access code to it. And teachers, once finish the loaning period until 28th, please return us the set from 28th to 31st, which is the end of the month, and we'll again start the loan process in November. So this is all about the highlight regarding the SNATOM molecular structures. We have about very short time left. We will stay like 5 minutes here. So if you have any question, please raise it up and we will give you the QR code for you to fill in, because this also marks the end of our sessions. So we actually have our contact written here. So you have any question that you want to direct to us, you can do it also. But if you are not rushing, that you would like to know more about the SNATOM program, you can also raise your question in the Q&A sessions. So please, you will need to attach your selfie photo in this QR code survey. So I hope you guys have no problem accessing this post survey, and also as well as the registration of interest to loan our SNATOM set. Yes, we will stay here for 15 minutes more. If you have any questions that you want to discuss right now, please let us know. I am Wenyun, and just now we have Mei Xuan and our assistant Anis of the day, Anis, that will continue this session until 12:15. No worries.